All right, in this video, we're going to be talking about a couple special angles and some special points. And we're going to piggyback right where we left off in class, talking about sine and cosine. So remember that sine of a particular angle, theta, is the y value divided by the radius. And cosine of a particular angle, theta, is the x value divided by the radius. So again, these are our very, very common ratios that we gave names to, sine and cosine. Alright, now there are three special angles that we're going to talk about today, and the first one is 45 degrees. Now remember, 45 degrees could also be referenced as pi over 4 radians. So I could use either one interchangeable, just so you know. So let's see here. Let's talk about 45 degrees. 45 degrees is right here, and it lands at some points. Let's draw a picture of this triangle here. So there we go. And I'm going to drop that straight down. So here's my x value, here's my y value, here's my radius, and here's my 45 degree angle. Now, let's try to find sine of 45 degrees and cosine of 45 degrees. Now, let's see here. How can I make this helpful? Well, to make this really easy to understand, we just simply have to remember something really important about 45 degree angles. So look at this triangle right here. This is a right triangle, because I dropped that straight down. And if this is 45 degrees, and this is 90 degrees, then this must also be 45 degrees. Now something special happens when you have a 45, 45, 90 degree triangle. Our hypotenuse is whatever value we want it to be. In this case, it's r, the radius. But our two sides, our two legs, must be the same, which means in this scenario, x and y are the exact same value. Should make a lot of sense since 45 degrees is directly in between, so x and y are the exact same value. So I'm going to use that to my advantage. Now, remember, in this triangle, we could use Pythagorean Theorem, x squared plus y squared equals r squared. So let's see here. Let's find a radius. Let's just say that this is a radius of 8. Okay? Let's assume we're talking about a radius of 8 here, a nice circle with a radius of 8. Well, that means that x squared plus, well, if x and y are the same value, then I could turn y squared into x squared equals 64. Again, all I did here was I replaced r with my radius of 8, and I have x squared, but y is the same thing as x when you're at a 45 degree angle, so I replaced the y with x squared. This gives me 2x squareds equals 64. This gives me x squared equals 32. And this tells me that x equals plus or minus the square root of 32. Well, let me clean that up real quick. That would be plus or minus, let's see here, 16 times 2 is 32, so that'd be 4 radical 2. Now, when we're in quadrant 1, obviously x has to be positive. So I just found that x is 4 radical 2, and since in a 45, 45, 90 triangle, x and y are the same value, then y is also 4 radical 2. Excuse me. So pretty easy to understand that. Now, let's go back to the questions I wanted to answer. What is sine of 45 degrees? Well, sine is the y value, 4 radical 2, over the radius of 8. Well, the 4 and the 8 will reduce, and I get radical 2 over 2. Likewise, cosine of 45 degrees is equal to the x value, 4 radical 2 over 2. 4 radical 2 over, my fault, the radius, which is 8. So I get the 4 and the 8 to reduce, 2 radical 2 over 2. So I find out that sine of 45 degrees is radical 2 over 2. And cosine of 45 degrees is radical 2 over 2. Now, one question a lot of people want to ask is, would that change if my circle had a smaller radius? Well, I'm going to try to draw a smaller circle here, not too pretty. But again, drop this down, and I now have, again, another 45, 45, 90 triangle, although it's a smaller one. So let's say that it has a radius of 5. Let's show that the exact same values for sine and cosine would occur. All right, let's come over here. Again, I'm just going to use the blue color to understand this small blue triangle. X squared plus y squared equals r squared. Well, x squared is the same thing as y squared because x and y are the same, so I'm going to make those both x squareds. And r squared is 25. So I get 2x squared equals 25. So I get x squared equals 25 halves. Square root both sides, I get x equals plus or minus 5 over radical 2. Now once again, I don't like radicals in the denominator, so I'm going to multiply the top and the bottom by radical 2. So I get x equals plus or minus 5 radical 2 over 2. So in this blue circle right here, this point right here would be x would be 5 radical 2 over 2. And guess what? The y would also be 5 radical 2 over 2, because in a 45-degree triangle, the x's and y's are the same. So now, when I come down here to try to find sine of 45 degrees is going to be the sine would be the y value, 5 radical 2 over 2, all divided by my radius of 5. Well, remember, dividing by 5 is the same as multiplying by the reciprocal. The reciprocal of 5 is 1/5. The 5's cancel, and look what I get, radical 2 over 2. So even though I used a different size circle, I still got that same ratio as I did when I was working with the orange values. So let's try cosine real quick. Cosine of 45 degrees is the x value, 5 radical 2 over 2, all divided by my radius of 5. Once again, dividing by 5 is the same as multiplying by 1/5. The 5's cancel, and I get radical 2 over 2. So what I just proved was it doesn't matter how big or how small your circle is. At 45 degrees, your sine is radical 2 over 2. Your cosine is also radical 2 over 2. Now, I really want this to hit home with a triangle, right? I really want this to make complete sense. So here's my 45-degree triangle, and that means that both angles are 45 degrees, which means that these two legs are exactly the same. So if this is x, then this is x, right? Well, let's think about this real quick for a second. Let's use Pythagorean Theorem. X squared plus x squared equals the hypotenuse squared. That's 2x squared equals the hypotenuse squared. Let's see here. If I take the square root of both sides, then that means that the hypotenuse is x radical 2. Once again, the 2 is still in the square root, but the x squared can come out as a plain old x. So, excuse me again, in this type of triangle, we get this ratio where our two legs are the same, and our hypotenuse is x times radical 2. Now, if we think about that for a second, when I once again do sine of 45 degrees, sine is the vertical height divided by the radius. That would be x divided by x radical 2. X's cancel. I get 1 over radical 2. I don't like radicals in the denominator, so I multiply bottom and top by radical 2, and I get radical 2 over 2. So it's just yet another way to understand that sine of 45 degrees is clearly radical 2 over 2. And I want to make this so crystal clear, so I'm going to do one more example. Let's draw another triangle here, and let's see here. If this is 3, then this is 3, if this is a 45-degree angle right here. And let's see here, 3 squared plus 3 squared equals the hypotenuse squared. That's 9 plus 9 is 18 equals the hypotenuse squared. Square root both sides. Let's see, 18 is 9 times 2. That's 3 radical 2 for my hypotenuse. So my hypotenuse is 3 radical 2. Okay, let's see here. Sine of 45 degrees is going to be the vertical height, 3, divided by the hypotenuse, or the radius, 3 radical 2. 3's cancel, and I get 1 over radical 2. But yet again, I don't like a radical denominator, so I multiply bottom and top by radical 2, and I get that sine of 45 degrees is radical 2 over 2. So I'm just trying to show you guys that it doesn't matter if you look at triangles or look at different size circles, different size triangles. 45 degrees, sine's going to be radical 2 over 2. Same thing with cosine. Cosine of 45 degrees is also radical 2 over 2. Hopefully that makes nothing but complete sense. All right, now another one of our, actually, I wanted to show this one more way. Again, I forgot that I wanted to really prove my point here. So I know you're probably getting upset with me, but I'm really trying to prove my point. All right, here's our other Pythagorean identity. This is that one thing we talked about in class that we know is true. Cosine squared plus sine squared equals 1. So what I'm going to do is I'm going to allow theta to be pi over 4. And by the way, pi over 4, same thing as 45 degrees. Doesn't matter if I use radians or degrees. All right, so let's see here. I know the cosine of pi over 4 we just got done talking about is radical 2 over 2, but I do need to square it for this formula to work. Sine of pi over 4 is also radical 2 over 2, but I need to square it for this formula to work. Well, let's see if this works. Let's see. Radical 2 over 2 squared is 2 fourths. Plus radical 2 over 2 squared is 2 fourths. Once again, 2 squared is 4, radical 2 squared is just 2. Does 2 fourths plus 2 fourths equals 1? Well, 2 fourths plus 2 fourths is 4 fourths. 4 fourths certainly does equal 1. So another way for me to finally prove to you that sine and cosine of 45 degrees or pi over 4 are both radical 2 over 2. All right, let's talk about our second favorite angle in the entire world, and this is 30 degrees. Now, this is going to be a little bit tricky to understand, so bear with me here for a second. All right, 30 degrees is approximately right around here. Drop this straight down. What happens here is I get 30 degrees. Now, if this is 30 and I have a right triangle, that means my remaining angle must be 60 degrees. Now, you need to look back to geometry. And this might be a little bit time ago, but if you remember back to geometry, a 30, 60, 90 is a special triangle. And in a 30, 60, 90, we know that across from the 30 is a particular value, let's call it W. Whatever that value is, the hypotenuse is automatically twice W. 2 W's. And whatever that, across from 30, whatever that is W, the other leg is W times radical 3. Now, you may be like, I don't remember that. Well, then you must not have paid a whole lot of attention to geometry. Well, this is a special characteristic of a 30, 60, 90 triangle. Across from the 30 is W, the hypotenuse is twice that value, and the other leg is W times radical 3. In order for you to understand what I'm about to do right now, you need to remember that. All right, so in this triangle right here, let's say that we have a hypotenuse of, or I'm sorry, this is the radius. I guess you could also look at it as a hypotenuse. Let's say that we once again have a radius of 8. Well, think about this. If the hypotenuse is 8, the side across from 30 must be 4. Again, because remember, the hypotenuse is twice the side across from 30, which means that the length down here must be 4 radical 3. So I'm just using this idea that I learned up here, and I know that this point right here is going to have a horizontal x value of 4 radical 3 and a vertical height, a y value of 4. Now I can find sine of 30 degrees, and I can find cosine of 30 degrees using what I just found out. Well, let's see. Sine is the y value 4 divided by the hypotenuse, or the r value, the radius. Again, I keep calling it the hypotenuse and the radius. It's the same thing. Hypotenuse is the radius. 4 divided by 8 is 1/2. Cosine of 30 degrees is going to be the x value, 4 radical 3 divided by the radius of 8, which reduces to radical 3 over 2. So once again, sine of 30 degrees is 1/2. Cosine of 30 degrees is radical 3 over 2. Now, what if I made the triangle, or I'm sorry, not the triangle, what if I made the circle smaller? Would that change anything? Well, let's find out. If I now made the radius of this orange circle 4, that means that the short leg is going to be half of that, or 2, and the other leg would be 2 radical 3. Again, I'm basing that all on my special triangle up here that you should learn about in geometry. So let's see here. Sine of 30 degrees is going to be the y value 2 divided by the I'm so sorry, divided by the radius of 4. 2 fourths is 1/2. Hey, same value I got up here. Cosine of 30 degrees is going to be the horizontal distance, 2 radical 3, that's my x, divided by my radius 4, and that reduces to radical 3 over 2. Once again proving that whether I talk about the orange circle or a larger black circle, I get the exact same values for sine and cosine. All right? Now, I really, once again, just like with the 45-degree triangle, I really want this to hit home. So once again, here's my setup. Whatever, if this is 30 degrees, across from the 30 degrees is going to be, I don't know, let's just say 10. Well, that means the hypotenuse is double that, or 20. And that means that the other leg is 10 radical 3. So that's how these are all connected. Again, you got to remember that from geometry. So let's see here. Sine of 30 degrees is going to be the vertical height, 10, divided by the hypotenuse, or the radius, 20. And we get 1/2. Crazy, right? Cosine of 30 degrees is going to be the horizontal distance, 10 radical 3, divided by the hypotenuse of 20, and then once again, I get radical 3 over 2. So I'm really trying to show you that it doesn't matter. If you look at it as different size triangles, different size circles, sine of 30 degrees is 1/2, cosine of 30 degrees is radical 3 over 2. Now, let's go back down here real quick, and let's talk about 60 degrees, because our other angle that we love is 60 degrees. Now, if you listen to everything I just said, I shouldn't have to talk very long about 60 degrees. Here's 60 degrees right up here. Now, I probably drew it a little bit off, but it's pretty close. Now, if this is 60 degrees right here, then this is 30 degrees. And here's my 90-degree angle. So I essentially have the exact same triangle, just rotated. So everything still remains true. So let me go up here so it's a little bit clearer to see. So all I have is the exact same triangle, just flipped around a little bit. Where here's 60 degrees, here's 30 degrees, and here's this, the 90-degree angle. Now once again, across from the 30 is going to be your W. The hypotenuse is 2W, and the other leg is W radical 3. So now, when I use this setup, let's just come up with an example here. Let's say that this is 60 degrees, this is 30 degrees. Let's say that this is 6. Okay, then my hypotenuse is going to be double that, or 12. My remaining side would be 6 radical 3. All right, so let's find sine of 60 degrees. Well, that's going to be the vertical height, 6 radical 3, divided by my hypotenuse of 12. The 6 and the 12 reduce, and I get radical 3 over 2. Cosine of 60 degrees is going to be the horizontal distance, 6, divided by my hypotenuse of 12, and I get 1/2. So what just happened? It's the same triangle. All I'm looking at is the other angle, which means I'm looking at it from a slightly different perspective, which means my sine and cosine switch on both accounts. So sine of 30 degrees is 1/2, whereas cosine of 60 degrees is 1/2. They switch. Cosine of 30 degrees is radical 3 over 2. Sine of 60 degrees is radical 3 over 2. So my values switch around. That's it, because all I'm doing is switching around that 30, 60, 90 triangle. So let's prove it with my formula one more time here, just like we did earlier. Okay, I'm going to replace theta with pi over 6, otherwise known as 30 degrees. And I'm going to do that for both the thetas here. And all right, let's see here. I just got done showing you guys that sine of 30 degrees is 1/2, and cosine of 30 degrees is radical 3 over 2. So I'm going to replace this, right? Pi over 6 is 30 degrees. So cosine of pi over 6 is radical 3 over 2, but it needs to be squared, plus sine of 30 degrees, which is the same thing as pi over 6, is 1/2, but it needs to be squared. And I get 3/4 plus 1/4 equals 1. And of course, 3/4 plus 1/4 equals 4/4, which is 1. Thus, proving that these values must be correct. Okay, so everything is connected is what I'm trying to show you with all of this, right? Everything is connected. In a triangle, we know that a squared plus b squared equals c squared. We know that if we have a triangle drawn from a circle, we know that the radius is acting as the hypotenuse. The horizontal distance across the bottom is x. The vertical distance across the top is y. And we know that x squared plus y squared equals r squared. And we also know that if we view this in terms of the ratios between x, y, and r, we know that, excuse me again, sorry, I got a cough, cosine squared plus sine squared equals 1. So 3 ways to understand the exact same concept. All right, so here's our final summary of our special angles. 30 degrees, sine of 30 degrees is 1/2, cosine of 30 degrees is radical 3 over 2. Sorry for a little bit of a typo there, radical 3 over 2. You know what? I need to just erase that and fix it for you. Okay. 45 degrees, sine and cosine are both exactly the same, radical 2 over 2. 60 degrees, sine of 60 degrees is radical 3 over 2. Cosine of 60 degrees is 1/2. Notice they switched from 60 to 30. But I get the exact same answers if I look at this in terms of radians. Pi over 6 is 30 degrees. Pi over 4 is 45 degrees. Pi over 3 is 60 degrees. When you use radians instead of degrees, it doesn't change your answers whatsoever. So, sorry about that. Hopefully, special angles make sense. Our 3 special angles are 30 degrees, 45 degrees, 60 degrees. Hopefully you understand how we were able to create these values, and it was fairly easy. But the key thing that I really need you to walk away from this video to understand is that everything is connected with these 3 formulas right here. Whether you're dealing with a triangle, you're dealing with a triangle embedded in a circle, or you're dealing with your trig functions, sine and cosine, it all comes together.